Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss applications of CRO. First application, study of waveform. As we discussed earlier or in that of previous video, a CRO is meant for giving a visual indication of the signal waveform on a screen which is provided with it. So, how we visually indicate that signal in terms of waveform? Let we discuss. First, we apply signal across vertical deflection plates. Let a sinusoidal signal under our study is applied to that of vertical deflection plates. Sinusoidal wave A, B, C, D, E is sinusoidal signal. That sinusoidal signal has one positive half cycle and one negative half cycle. The upper plate becomes positive during positive half cycle and hence the electron beam is deflected upward. However, the positive potential on the upper plate increases from 0 to a maximum value and then come to 0. Accordingly, the spot moves off from a particular position. That position we show in that of vertical lines. Vertical lines from that of vertical plates. In vertical lines, the positions are A, C, E, A, C, E. Here point B and D, it will name it as A and B. During that positive half cycle, the spot moves off O to A and then comes back to O again. The lower plate then becomes positive during that negative half cycle and hence the electron beam is deflected downward. At that of case, the positive potential on that of lower plate increases from 0 to a maximum value and then comes to 0. Accordingly, the spot again moves down from O to B and then comes back to O again, the sinusoidal wave when given to that of vertical deflection plates. So, in vertical lines we see that observations. So, in fact we say the spot moves up and down as per the frequency we applied in that of particular sinusoidal signal. If we apply a frequency of 50 Hz, just an example, it means that spot moves 50 times in 1 second along that of vertical line between the point A and point B. So, our persistence of vision is about just around 0.1 second. So, we will see a continuous vertical line AOB on that screen. The line can't give actual waveform of that of applied sinusoidal signal. So, we have to need the help of a sawtooth wave. In the next step, we have to applying a sawtooth wave across horizontal deflection plates. First we apply the signal across vertical deflection plates. We observe that vertical lines, then applying a sawtooth wave across horizontal deflection plates. This is step number A, this is step number B. First, a sawtooth wave. Negative potential, positive potential. One, 2, 3, 4 and 0.5. The beam moves up and down due to the applied signal in each cycle. In order to obtain the visual waveform, that beam should simultaneously move horizontally from left to right. This is a sawtooth wave. What we observe in case of horizontal deflecting plates, it is a horizontal line, the points P, Q. So, what we observe in that case, that horizontally that beam should simultaneously move horizontally from left to right during that of same time. Therefore, a sawtooth wave is applied to that of horizontal deflecting plates, which moves that beam from left to right at a uniform rate. The circuit which produces this voltage, we call it as a sweep generator or time based generator. At initial time when t is equal to 0, the right plate is at highest negative potential. So, the electron beams is deflected to the extreme left position. That is P. As the negative potential on the right plate decreases with time, the beam moves toward the right through the middle point O with a uniform speed. Finally, the highest positive potential on the plate deflects the beam to the extreme right position Q. 3, 4, extreme right position, observe 5. Thus, that sawtooth wave moves the beam from left to right at a uniform rate. We will see a horizontal line POQ due to that of given sawtooth wave only in the absence of applied sinusoidal signal to that of vertical plates. Now, on the combination of these two, we can visible that particular applied signal on that of screen. In third step, visible signal pattern on screen. Here is the output of a V plates, vertical plates, outputs of vertical plates as A, C, E, here B and D is the output of V plate. It is combined with the output of horizontal plate. This is the output of horizontal plate. Output of horizontal plate 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Output of horizontal plate. When we combine these two by using the trigger circuit and a time delay line, so finally on the screen we obtain the signal just a sinusoidal wave. Here the time period is 4t. At that point A and again this point 1, so A minus 1. Here the point, here B 2, next point C 3, that point D 4, this point E 5. Since we consider a time period of 4t at initial time t is equal to 0, the spot would be produced at A due to a signal, but it will be deflected to position 1 due to that sawtooth wave. Thus, a point A minus 1 is obtained on that of screen to the extreme left side. Similarly, at time t, time 2t, time 3t and time 4t, we obtain just that kind of wave pattern on screen. This is the wave pattern on screen. In this way, by applying cathode ray oscilloscope we visualize the waveform. First, that signal is applied to that of vertical deflecting plane, then sawtooth wave across that of vertical deflection plates. When combining these two by taking the trigger circuit and delay line, finally we observe the wave pattern on the screen of that particular cathode ray oscilloscope. Next application of CRO, by using cathode ray oscilloscope, we study of the measurements of voltage, current, frequency and phase difference. First of all, how we measure voltage? Measurement of voltage. Measurement of voltage. Basic principle is used to measure voltage by using CRO. We know that the deflection on CRO screen, the deflection we observe on that of CRO screen is directly proportional to the voltage applied across the deflecting plates. If voltage is high, then the deflection is high and vice versa. So, we know that the deflection on CRO, cathode ray oscilloscope screen, is directly proportional to the voltage applied across that deflecting plates. Deflecting plates, two pairs of deflecting plates, horizontal plates and vertical plates. So, how we measure the voltage? Let me take a unknown voltage which can be measured by using that particular principle. An unknown voltage is measured by using that principle. How? So, when direct voltage to be measured is applied across the vertical deflection plates in the absence of that sawtooth wave, so the voltage, that voltage may be AC or DC, AC or DC. That is alternating or direct, alternating or direct. So, in case of direct voltage, when we measured across that of vertical deflection plates without the absence of sawtooth wave, so the internal horizontal sweep generator is shut off. The signal will give a vertical line whose height is proportional to the voltage of applied signal under that study, and that particular value of voltage can be measured by multiplying the deflection with the deflection sensitivity. And same thing we processed for direct current. Now, mathematically we have to show it how a unknown voltage is measured. So, let we prefer, let deflection sensitivity is equal to S millimeter per volt. Deflection sensitivity, that is the measure of deflection towards what be the change in voltage. Next, length of vertical line, length of vertical line may it will be given as L millimeter. Length in vertical line, as we say that deflection is directly proportional to the applied voltage that can be measured to that of vertical line. What be the potential we applied? Next, therefore, the value of unknown voltage is calculated as deflection sensitivity and length of the vertical line, L into S volt. Okay, that be the formula. By using that formula, we can easily calculate the unknown voltage. So, by applying that CRO, we measure the unknown voltage. That voltage may either alternating or direct. That is AC or DC, alternating, that is alternating or direct. Next, how current can be measured? Measurement of current, measurement of current. That current again direct current or alternating current. Mainly we can measure voltage by using cathode ray oscilloscope, but this is another measurement of current, but we can't use an oscilloscope directly to measure electrical current. However, electrical current can be measured indirectly with an oscilloscope. How? For this, we have to consider a resistor, known resistor. For this, we have to take a known resistor whose resistance we have already known, and that resistor is connected to that of CRO. And the current is measured on that of resistor by taking the potential drop across that of resistor and using the Ohm's law. From Ohm's law, using Ohm's law, as current is equal to voltage divided by resistance. Resistance is known to us, voltage again we know by using that method. So, what be the voltage across that of resistance, on that of basis current can be calculated. Next, measurement of phase. measurement of phase with cathode ray oscilloscope. Basically, we measure the phase by taking the Lissajous figure. From that of Lissajous figure, is the path followed by two perpendicular harmonic waves, or the path followed by the particle when these two particles are represented by two harmonic waves. When these two are superimposed with each other, the resultant is given to us in the form of Lissajous figure. If a wave is a signal of wave having the potential is given to us, the x component is given to us as a sin omega t, and its y component Vy as a sin omega t plus phi, where phi is the phase difference, that wave is phi phase default. Now Vy as a sin omega t plus phi, sin of a plus b, sin a cos b plus cos a sin b sin phi. Again we have a cos omega t is equal to a square minus vx square under root. Now putting this, we have substituting that value, the values of cos omega t, a cos omega t and a sin omega t in the expression for Vy, we get. So putting that value and solving, we achieve equation as Vx square plus Vy square minus 2 Vx Vy cos phi a square sin square phi, that is a equation of ellipse, an ellipse. That ellipse is obtained on that of screen. We obtain the ellipse just like this. Here is the A, this is the Vy vertical potential, x axis, that is y axis. So at initial time at t is equal to 0, Vy is equal to a sin phi, therefore phi is equal to sin inverse Vy by a. So phase difference is calculated just like this in case of CRO by taking that Lissajous figure, that is the Lissajous figure. Lissajous figure. Lissajous figures, it is an ellipse. Next one, how we calculate frequency by using the CRO. Measurement of frequency. Measurement of frequency by using CRO, cathode ray oscilloscope. Same thing, it can be obtained by taking the Lissajous figure. How? If we take a Lissajous figure, is given to us. As the 8, the Lissajous figure. From that of Lissajous figure, how we measure that frequency? Draw the vertical and horizontal lines. Here in that of section we draw as Vy for horizontal plates as the wave signal A, B, C, D, E, F, G, H. Now here for Vx, the signals are signals are 0, 1, 2, 3, 4, 5, 6, here 7, here 8. Now joining the lines, when joining these lines, so that line as a 0, 0, here the point is 0, 0. Next here we take 1, here we take A, so at that point we have 1 A. Next that point as 2 B, 2 B, this point 3 C, that point 4 D, this point 5 E, just joining it. We already know how to draw the Lissajous figure. Next 6 T, 6 F, 6F, that as 7G, 7G. This is the Lissajous figure for frequency of CRO. How frequency is measured? Look here, what be the number of tangents? That tangent play the major role for calculating the frequency. In order to obtain that pattern, a tangent at the top edge touches the figure twice. Here it touches that figure twice, 1, 2, but in the lower end it touches the figure at once. Here touches 2 times, it touches 1 times. It has 2 horizontal tangencies. The frequency of a vertical signal is proportional to the number of horizontal tangencies. Frequency of vertical signal is proportional to the horizontal tangency. So the frequency of a vertical signal, so its frequency is equal to 2k. The frequency of that horizontal plate is 2k. Same thing, similarly frequency of vertical line touches once, so it will be k. This is the frequency of vertical line, the frequency of vertical line. Similarly frequency of horizontal signal is equal to k. Horizontal signal, it touches once, the frequency is k. So finally the ratio of vertical to horizontal is the ratio of vertical to horizontal signal is equal to 2k is to k, that equal to 2 is to 1. Okay. In this way we calculate the frequency by using CRO. As we know, the ratio of the frequencies of horizontal to vertical signal, if any one of that of signal we have to measure, one is given to us, another one is easily measured by using that relation, or by using that Lissajous figure we first achieve what be the ratios, then calculating the frequencies. So here with the help of this video lecture you understand applications of cathode ray oscilloscope. One application as study of waveform, how we visually show the waveform on the screen by taking the CRO. Next application, study of measurements of voltage, current, frequency and phase difference. First voltage is measured, next current, we manually measure the current by taking the unknown resistor. Next phase difference, by taking the Lissajous figure, from that Lissajous figure the phase difference is calculated. Next measurement of frequency is calculated, from that of Lissajous figure the number of tangents touching to that of figure is just the indication towards the frequency. So the horizontal and vertical frequencies ratios are calculated. In that way the frequencies of the given signal, given wave signal is calculated by taking its Lissajous figure. So with this useful and informative notes, let me wind up this session. Thank you.